All right, guys, this is 11.3, and this section is pretty intuitive. I want to introduce the concept of a sector. A sector basically is a section of a circle, and if you look at the shaded area, and this area is hugged by these two radius, right? And as well as this part of the arc. So it's bounded by a central circle and its intercepted arc, and that's what we call a sector. And it looks like a slice of a pizza, basically. So write it down, and then copy down this formula, and this tells us how to calculate an area of a sector. So once you finish, let me add a blank page. I want to demonstrate to you what appears to be complex formula really means. I like to write it this way, okay, because it helps me to think. It's really a percentage question. So let me give you an example here. If I want to tell you that between point A and point B, this segment is 10 meters. But if I tell you C is about, say, 30% of the length of AB, AC equals 30% times AB. So since AB is 10 meters, and then you just plug it in, right? Your final answer is AC equals 3 meters. It's that easy. Now I can elaborate that into an area question. So if I have a rectangle, I can say this is 10, that's width, and this is 5, that's length, right? So if the area equals width times length, so the total area equals 10 times 5 equals 50. So the whole thing is 50. Now, if I change my color and I say I want to know just this slice, and I will tell you that this slice is 30% of the total area. And so then I do the area for red is 30% times 50. This is square meters. So 30% times 50 would give me 15 square meters. It's a percentage question. Now let's look at the area of a sector. If I know the area of a circle is pi r squared, then if I also know that the entire circle measures 360, right? And if I just let x equals the measure, angle measure, this is angle measure or degree measure of the central circle, then I put x on top. That gives me a percentage. So I use that percentage multiplied by pi r squared. That would give me the area of the sector. So I'm going to erase part of this just so that I can demonstrate this. Let me erase this example here. So let's see. So if I draw a circle, so for example, if I draw a circle here, and I tell you the R is 5 centimeters. So I know the total pie, area of total pizza is pi r squared, which is pi times 5 squared, 25 pi. Now, if I take out this slice here, and I tell you this area, which is also this arc, and let's say that's 30 degrees. Since I know the whole thing is 360, all I need to do is to use the 30 divided by the, what I just say, 30 divided by 360, sorry. That gives me this percentage of this shaded area out of the whole pi. So this is a percentage. And I use that multiplied by pi r squared, which is my 25 pi. So then that's 30 divided by 360. I'm not going to use my calculator, but whatever this answer is the area of that shaded sector. Okay, so let's now go back to some of the practices. So I'll do a couple of these, demonstrate a couple of these, and then the rest of it, you can do it on your own, right? So again, it's read the question first. You're asked to find the area of the shaded sector. So then we would know, I want to know the central angle over 360 and then pi r squared. That's the formula. So let's see. I'm told BC, which is my radius, is 16 feet. So I just plug it in right there. And then do I know my central angle? 51 over 360. And you set this up. That's area equals 51 over 360 times pi r squared. And that should give you approximately 113 times 94 square feet. So let me jump to number 4. GH over here, that's 13. So that's my R equal 13. So again, if I'm looking for shaded area, I don't know the central angle, but I know this part is 160. So first of all, I have to find the angle measure of GI, which is 360 minus 126. That should give me 234. Now I've got everything I know. 234 over 360 give me that percentage times pi r squared. R is 13. And then you use your calculator. That should give you 345. And in this case, be careful with the units. It's yard squared. Let me see if I can do another one. Number 6. EF equals 28. So that, again, is my radius. Right? And then I already have the central angle. So it's a simple plug-in. Find the percentage, 115 over 360. And then pi r squared. R is 28 squared. That's my area. So in this case, you should have 786.79 square meters. Let's do number 14 on this one. These things, this section is really easy, so I won't do a lot of demos. So number 13, I have, I don't have the radius, but RS is the diameter of 43. So radius is simply 43 over 2. Then I know this area is, this angle is 17, then this is vertical. So PTR has to be 17. But what I really need is the shaded area. So it's simply 360 minus 17 times 2 over 360. That would give me the percentage. Then I multiply it by pi r squared. That's the setup. The rest is all calculator work. And the final answer is 1315.05 square meters. Okay. Last one. Let me make this a good one. So PC, this is my R. PC is my radius. It's 12. I've got shaded areas, 3 parts. I'm also told these three arcs length are congruent, which really means this is 62, this is 62, meaning the central angle, they are the corresponding central angle are also congruent. So now I can calculate, if I use 360 minus 62 times 3, that gives me the sum of the three angles in white. I put that over 360, give me a percentage, pi r squared, r is 12. That's the setup. Your final answer is 218.65. Okay, that's it for this section. It's not hard at all. So practice, make sure you finish all the independent practices, and don't forget the homework. Thank you guys. Bye.